Welcome to Study Loop.
In this problem, we have an arrangement of a square where there's charges on two of the corners of the square. So the orientation is not unique, but for this point, I'm going to choose it to where Q1 is here, Q2 is here, and then they tell us that point A is in the middle, and point B is on the corner closest to Q2. So that would, for my picture, mean that B is up here. Now they tell us that each side of this square is 3 centimeters. So that means it's 0.03 meters. And then they give us some of these values. So Q1 is equal to plus 2 microcoulombs. Q2 is equal to minus 2 microcoulombs. Okay? So now what we need to do is we need to figure out some of these lengths here, because we're going to have to know these lengths in order to calculate the potentials. So first I'm going to do this triangle that I have drawn here. So this triangle is simply 0.03, 0.03, and then A will be in the middle, so whatever we find the hypotenuse to be, the length from Q1 to A will just be half of that. So we have that the hypotenuse is equal to the square root of 2 times 0.03 squared. And there's a 2 here because both sides are the same. So this tells us that the hypotenuse is 0.0424 meters. Okay? And so now our radius from 1 to A, which will also be the same as the distance from Q2 to A, since we have symmetry here, is equal to half of this number, which is simply 0.021 meters. Okay? So now that we have this, in part A, the book is asking us to find the voltage. So remember, the voltage for a point charge is simply Q over 4 pi epsilon naught r. And then you must add up the voltages from every charge. So if we're trying to find the voltage at point A, we need to find the voltage at A due to Q1 plus the voltage at A due to Q2. So we can do that. The voltage at A will be equal to Q1 over 4 pi epsilon naught R1 plus Q2 over 4 pi epsilon naught R2. But since R1 is equal to R2, this is simply equal to Q1 plus Q2 over 4 pi epsilon naught R1, or R2. And then we see that Q1 and Q2 actually have the same magnitude but opposite signs. So when you add them together here, you're going to get that the voltage at point A is simply 0 volts. Okay? And that's it for part A. So now if we move on to part B, the book is asking us to find the voltage up at the top of our square at point B. So just to remind you, this is point B, this is Q1, this is Q2. Okay? And we already found that this length here, okay, which is R1 in this now, is equal to 0.0424 meters. So now we just do the same thing we did in part A. The voltage at location B is equal to Q1 over 4 pi epsilon naught R1 plus Q2 over 4 pi epsilon naught R2. But now R1 and R2 are different values. R2 is just the side of this square, the distance between Q2 and B. So this is simply 0.03 meters. And now you can simply plug in these values, being very careful that Q1 and Q2 are in microcoulombs, so you must convert into coulombs. And you'll find that the value is negative 1.75 times 10 to the fifth volts. Okay? And the reason this is negative is because Q2 was actually a negative charge. So you get a negative answer when you plug it in. Now in part C, we're going to have a point charge Q3 equal to negative 5 times 10 to the negative 6 coulombs. And it's going to travel from point A here up to point B. Okay? And we want to figure out how much total work is done as that point charge is moving from A to B. So we can simply remember that work is equal to negative delta U. So this will be equal to negative U final, which is UB, minus initial, which is UA. Okay? So this will simply be equal to UA minus UB. And now we just remember that U is equal to Q naught V, where Q naught is the charge that we're considering moving or changing potential energy. So this will simply be equal to Q3, since that's what's moving, times VA minus VB. Okay? So now we know VA is 0, so this whole thing goes to 0 here. And what we're left with is simply the work from A to B is equal to minus Q2 times the voltage at point B. The voltage is negative and Q2 is negative. So when we plug in these values, we find that the work from A to B is simply, this is a Q3, is simply minus 0.877 joules. And this work is negative, which is as we would expect, because a negative charge, charge 3, wants to move from low to high potential, and VB is at a higher potential, so it's trying to move to that point.